So one, something we know about quadrilaterals, all quadrilaterals, the angles sum to 180 degrees. That is always true of all quadrilaterals, okay? So when we're looking at those, we can always add up all the angles and they equal 190, okay? Or 180, not 190, 180. So then we talked about parallelograms. Okay, and anything that fits under parallelograms also has these things that are true about parallelograms. But in parallelograms, the opposite sides are equal. Sides are equal. And parallel. Okay. Two opposite angles are equal. So if it's a or a parallelogram, that's true of a rectangle, that's true of a square, because they are also parallelograms. It's also true of a rhombus, because a rhombus is also a parallelogram. So all those fit into there. The other one is that the diagonals bisect each other. Okay, so in any parallelogram, the diagonals bisect each other. So then that is true of squares, that is true of rectangles, that is true of a rhombus. So for all those, you can say that that's true, because this fits all the things that are underneath it. Okay. So then we went into a little bit more on parallelograms. That's telling you can go backwards. If you know that two angles are, the opposite angles are equal, then you can say it's a parallelogram. If you know the opposite sides are equal and parallel, you can say that it's a parallelogram. And if the diagonals bisect each other, you can also say it's a parallelogram. So you can go backwards from that. Okay. So in a rectangle, which remember, a rectangle is also, so everything up here is also true for a rectangle. It fits underneath these. Okay, so 1, 2, 3 above is true. The fourth one of a rectangle is that the diagonals are equal. Okay, here the diagonals are not necessarily equal, but we know they cut themselves, it cuts in half. Here's the diagonals are equal. So that's something we can know when we get to a rectangle. That's also true of a square, because a square is a rectangle. So anything that falls under each of these categories it's also true. Okay. We also know that if we go, so one other thing, a rectangle is one way. In a rectangle, we have all 90-degree angles. So you could say all angles are equal. That's another way of saying it. Not all sides are equal in a rectangle. Okay, but you do have all 90-degree angles. A rhombus is a little bit different. Okay. A rhombus goes down and it has 1 through 3 that's also true, because a rhombus is a parallelogram. But it doesn't have 90-degree angles, and the diagonals are not necessarily equal, but the diagonals are perpendicular. Can't write that very well. Okay, so here the diagonals are equal. Here the diagonals are perpendicular. Okay. a square is kind of like a rhombus, but it has all these things that are true of the rectangle, so it's number 1 through 5 above. And then it has 6 would be that it's all sides are the same. And 7, it is true that the diagonals here are also perpendicular, because it fits kind of like the rhombus. When the sides are equal, the diagonals are perpendicular. Okay, so that's stuff that we can say about those. Okay. And then we went into one that really isn't related to anything. It's kind of up above. It's the biggest category of quadrilaterals, which is a trapezoid. And in a trapezoid, it's where only one pair of opposite sides is parallel. Okay. And number 2, we define an isosceles trapezoid as a trapezoid with non-parallel sides are equal. Okay, if that's true, then the base angles, actually this kind of is 2A, the base angles are congruent. Okay. So that's some of the things that you can look at with isosceles triangle. And the diagonals of an isosceles trapezoid, the diagonals are equal. So this is kind of a summary of what you can tell and that what you have to have rectangles, rhombuses, parallelograms, trapezoids, squares, etc. So it's classifying it down. The other one, the other kind of quadrilateral, which we really didn't talk about in this section, but I like to throw it in, is the kite. Okay, the kite has 4 sides. It's the 2 adjacent sides are equal in a kite. And when you do the diagonals are actually perpendicular in that too. So a kite is kind of this weird person over here, this weird category. Okay, it has 1, the adjacent pair of sides are congruent. Okay. 2, its diagonals bisect each other, and its diagonals are perpendicular. So it's given a special name. It doesn't really fit into these. The kite is not a trapezoid, it's not a parallelogram, it's not any of those, okay? Because it is more like this, where you have the 2 top sides are the same and the 2 bottom sides are the same. So that's what defines a kite. So they're not parallel to each other, and opposite sides are not equal, which all of these we have opposite sides, at least some opposite sides that are parallel. So that's basically what you have there, okay? That's a summary of all the quadrilaterals that we've looked at so far, okay? We've done some things with those. Okay? So if you want to say it's a rectangle, you have to have at least down specified that they're 90-degree angles and either the diagonals are equal or the opposite sides are equal and parallel. So this is more specific. If you know it's all 90-degree angles and it's a parallelogram, then it is a rectangle, okay? Here you have to have all sides equal and all 90-degree angles and the opposite sides are parallel, okay? Here we don't have to have opposite sides. Opposite sides have to be parallel. All of them are equal. Oh, I didn't write that down. All sides are equal. But if it's a rhombus, it's not necessarily a square. Okay, it can have slanted angles. But they will be perpendicular. Because all the sides are the same, they will be perpendicular. So there's times when things are perpendicular, and that's really when you have a square, a rhombus, or a kite, then your diagonals will be perpendicular to one another, okay? Not necessarily in a rectangle and not in a parallelogram unless those are a square or rhombus, okay? So you have to, those are the kind of things that you have summarized. This is a good thing for a test. If you have this written down, you can easily refer to this and say, oh, these are the reasons why. Okay, so it's something that you can use on a test, and it's very easy because we've summarized all the different categories and the different things that we've looked at. Okay. So today what we're going to do, besides just summarize this, that was the one part, we are just going to do some proving of a few things. When, like yesterday, we talked about that it was half when you drew midpoints and all that. We're going to show that on our coordinate graph today. We're going to actually be able to calculate that something drawn and you take the midpoints and make another thing inside of it. That is then going to be half of the original. Okay, so let's start with just a plain old rectangle in here. Draw a rectangle. We're going to make the rectangle nice and easy so we can see it. We don't have to do a ton of work. But we're going to review a little bit first. Okay? Did I erase it too fast?
Yeah.
Oh, sorry.
Sorry.
Take a picture of his.
Was there a third thing for the kite?
There's only two things, right?
Yeah.
Oh, you can get anything for a kite. Well, a kite is where the the top ones are equal. So the two adjacent pairs are equal. Two adjacent pairs of sides are equal. Okay.
And the diagonals bisect each
And the diagonals bisect each other. I don't think I gave you anything else because diagonals are not equal in a kite. They don't have 90 degrees necessarily. They can, but they don't have to. Okay, so that's about, and then I drew a picture of one. Just a little picture of one. Okay. Are equal. The two pairs of adjacent sides are equal, so we have two sets of adjacent sides that are equal. Okay. So we're going to start with this old rectangle here. Just because I'm going to make it, we'll go to here and to here. Okay, so on your paper, let's draw our rectangle ABC. Okay. This is 1, 2, 3, 4, 5, 6. So this is 6, -6. This is 6, 0 on this point. This point over here is negative, wait. Yeah, I did. -6, 0. and this one is -6, -6. So there's your 4 corners, okay? So we're just drawing a plain old rectangle. I did it this way so we could easily find midpoints. Yes,
Isn't that 5?
is that 5?
5, 0.
It's supposed to be 6 because I want it to be easy. So we're taking it out to 6. Believe what I wrote here and not what I drew on the board. Thank you for clarifying that. Yes, that's true.
I can't believe I miscounted.
Well, I miscounted too,
I
so.
counted 6.
You counted 6 and I thought I did too, but you know, we can't count, I guess. Harrison, that's the moral of the story. You and I cannot count.
It could be sharper.
Too sharp?
Not sharp enough, probably. Could be breaking enough.
Yeah.
That's what I'm
Okay,
It's only these pencils though.
find the midpoints of your sides. Well, I was trying to do this in a different color, but,
So we don't.
and mark your midpoints. And then we're going to connect those.
Connect your midpoints. Do you want us to make the sides of the rectangle or just the points for the corners?
No, you should make the side so you can see it.
Okay.
Now we're connecting the midpoints.
This is a funky looking square.
Is it a square?
No.
Excuse me?
Right away, it's funky looking.
Might be. How would you, so look at what you think that is. What do you think that is? This is with a rectangle.
Rhombus.
It looks like a rhombus. Now, how would we be able to prove it's a rhombus? What would we have to know about it?
If all the side lengths are equal.
Yeah, we'd have to know if the side lengths are equal. So how can I prove if the side lengths are equal here? I want to have, let's label some of these. We're gonna call this A, we're gonna call this B, we're gonna call this C, and this D. Whoops. How can I prove that AD, AB, BC, and CD are all the same length? We want to prove that AD plus AB plus BC plus CD are equal. I don't want to say plus, I'm going to say that they're equal. Now we have it on a coordinate graph, so we don't have to do anything with triangles here because we have a coordinate graph. How could I prove that those are all equal? What would I do?
Could you count? Or like,
Could I count? How do we find,
Equation.
yeah, what's the equation? Can't I find distance?
You could do, you have the D equals and then you'd have,
Yeah.
here we are.
So what you look at, and we have the triangles already, so you don't even have to look at it, but you would take the length squared plus the height squared of each triangle. So my length is 6 squared plus my height is 3 squared, and that's going to be 36 plus 9, which is equal to the square root of 45. We're not going to talk about, we're just going to leave it as square root of 45 right now. It's not a perfect one. We're just going to leave it there. Okay. So, yeah.
Can you also do, oh wait, no, I'm thinking a bit different, sorry.
You can do the x1 minus
Yeah,
the x2. It gives you the same thing.
Okay.
I like
As
it.
long as
I like to look at it because I have a triangle
Yeah.
already here. Why not use it? Is this going to be the same numbers inside?
Yeah.
It's going to be 6 and 3. Going to get the same thing. Is this one going to be 6 and 3?
3 and 6, yeah.
Yes. Is this going to be 6 and 3?
Yeah.
Yeah. So they're all going to be that same distance. Okay. So this is the same for all, so we know that those are, okay, the same length. They're all the square root of 45. Okay, that's because I made the numbers very easy and I put it on there so you didn't have to do much work. Okay. What else do I have to know if that's a rhombus? I have to know that the sides are all the same. What else do I have to know? What's the definition of a rhombus?
Oh, the definition of rhombus.
That's the,
If the sides are all the same, does that actually make, this is a question for you, does that make it the thing that we need it to be? Yeah, it does actually, but
I think
what is the thing we need it to be?
rhombus,
A rhombus is a type of what?
parallelogram.
It's a type of parallelogram, so we need to know the opposite sides are parallel. Can we say that if they're all the same?
Yes,
How come?
because if they're all equal, then the opposite ones are gonna be equal.
Okay, because if you're looking at them, what's the distance between these two lines? It's the same amount, right? It's a square root of 45, so they have to be parallel. Because parallel lines are always equidistant from each other. Okay? If I look at these ones, it's the same thing. The distance between them is the square root of 45, both of them. So those lines have to be parallel. Okay? Now let's just go one more step. We're going to go and take the midpoints of this. Not as easy, right? Okay?
Yeah.
So how do we find the midpoints? Let's figure out what is the midpoint from this point. So let's write these points down. Let's write them in red, so it matches. So the midpoints of these are 6 and -3. Okay, this midpoint here is 0 and 6, -6. This one is 0 and 0. And this one is -6, -3. Okay. If I want to find the midpoints, now it's a little harder of each of those. What would be the midpoints? What would be their values? Okay.
Wouldn't it be the square root of 22.5?
Where'd you get the square root of 22.5?
That's
Oh,
just half
that's
the
just
whole
the distance. You don't have the actual points.
Right.
How do we find midpoints of 2 points? So if I want the midpoint of 0, 0, and the point 6, -3, how do I find the midpoint?
Do you add them? No, never mind.
I want to find the midway between these two, right? What's the midway between 0 and 6?
3.
3, okay. What's the midpoint between 0 and -1.3?
1.5.
-1.5. Okay, let's see. We go down 3 and -1.5. Oh, look at that, it's the midpoint. Okay,
It's fancy.
so let's look between 6, -3, and 0, -6. It's going to be 3, and from -3 to -6, it's going to be -4.5. You guys all figure that out? How I got that? -4.5 is the halfway mark between -3 and -6. You guys agree with that?
Mm.
Because this is a step of 3, so I took 1.5. So I added 1.5 to this, but I know I'm going negative, so it's -4.5. Okay, so let's see, 3 and -4. Well, it looks right about right there. Okay, can we guess where the other ones are going to be? Okay, so here it is. It's going to be right over here and right over here. Okay. Huh. What do I get there? Oops, I didn't want to draw. I wanted to draw that one blue. Just a minute. This one's going to be blue. So we can see it better. What kind of shape does it look like I got now?
A rectangle.
A rectangle. We went from a rectangle to a rhombus to a rectangle,
Let's get it back to wrong.
okay?
Oh no.
How could I prove that that's a rectangle? What do I have to prove about it? Yes,
90-degree angles?
90-degree angles. True. Okay, how do I know that there's a 90-degree angle there? What kind of,
Well, you could look at the midpoint of the diagonals.
okay,
If you bisect each diagonal, and it creates a perpendicular line.
okay. So when we're doing this, this is a vertical or horizontal line, right? Does everybody agree with that? This is a vertical line. Horizontal lines and vertical lines are 90 degrees to each other, okay?
Yeah, 'cause
Now-
one's half.
Yeah,
Yeah.
if we had something that was in a different spot, you would have to look to see if the slopes between those lines or between the points were the opposite inverse. That means one's positive, one's negative, and the opposite reciprocal. Okay, and you'd have to have one flipped. So that's how you did otherwise, yes.
Can you also check if they're just parallel then?
Yes, you could.
Is that
Yeah. You could check if, but we know it's parallel. This is vertical, this is vertical, so they're parallel. This is horizontal. Oh, I did that wrong. This one's vertical, this one's vertical, that one's horizontal, that one's horizontal. So they are 90-degree angles, okay? Because it nicely worked out that way on there, okay? Now, if I took the midpoint, we're gonna go back to black, of this, which again, these are pretty easy to find, pretty easy. That one's right there, that one's right there. Where is this one?
It's right there.
It's right there, okay, right here?
Mhm.
Okay, what do I get again now?
Rhombus.
Another rhombus, okay? What will I continue to get if I continue to take midpoints?
rectangle and rhombuses?
Yes, rectangles, rhombuses, rectangles, rhombuses, rectangles, rhombuses, okay? That's called an infinite series. I can continue to do that until they're minuscule, okay? It's an infinite series. This infinite series is made by just connecting the midpoints of the figure, but it goes rectangle, rhombus, rectangle, rhombus. Okay. Now I have a question. What do you notice about the size of this rectangle versus the size of the big rectangle? Anything you notice?
Half the side.
Is it half the size?
Coordinates.
Is it quarter the size?
I think it's half.
Prove it to me. Come on, there aren't too hard. What is the length of one of the sides of the big rectangle?
12.
Okay, so it's 12 across here.
The second one was 6.
What's the one down here?
6.
It's 6. What's the length of this side?
6.
And what's the length of this side?
3.
3. It's actually 3. Okay, so how is this compared to that one? It's half. Is that true here? Ooh, that'd be a little harder to figure out, but you could determine if it is half if you do the distance formula. Okay? This is called an infinite series. So one of your things for over the break, okay, is to come up with an infinite series and color it different ways. Now you could go through, and so you could make a whole pattern on your paper of this infinite series going down as tiny as you can get it, okay, and then putting another one next to it and making a whole bunch of infinite series, okay, and that will be basically you're just doing it to see what kind of look it gives you, and how you color it will give you different looks, okay, so you can, and then you would just describe how I made it. I did it, I started with the rectangle, I connected the midpoints. It gave me a rhombus. I connected the midpoints and so you're explaining how you did it, just that's as easy as it is. But I want you to color it to see how color changes how it looks. Because how you color that will give you different little things to do. Okay, yes?
So do you only want us using four-sided shapes?
No,
Okay.
I'm gonna let you use anything you want. I'm gonna show you right now some that are done that you can play with.
Yeah,
Can you do
square would
any
just
shape?
go
Triangle?
It has to be, well, actually,
twit.
well, I want you to describe how you did it, but let me show you a
I
few.
mean, you could make it look cool, but it would just be every
Okay,
other.
just a
one.
minute, I have to find it now. Yeah, you can do all sorts of things like this.
An octagon. That would
can
actually
do
look
whatever
cool
shape
because it
I
can only
want.
tilt a little bit, so like go down. That might actually be cool.
Those are not, sorry, I have to
Okay,
find
well,
it.
octagon. What is that?
5 hexagons.
Oh,
Uh,
oh dear.
Geometric, there we go.
30.
30 goes.
Okay,
30.
so there's a lot of different ones here, some, I know those are harder to see.
The triangles look nice.
So this one is a triangle thing where they keep doing some stuff there. You need to figure out and describe exactly how that's formed when you're doing it. There's things, this is called the golden spiral, okay? Golden ratio spiral. And so that's another one that you could do. You can do, some of these have not been colored. They're showing you the colors.
I have mine.
Okay, so those are things you could do. This one is, where'd it go? Oh, come on. You can't see it. Okay, it's got a bunch of little triangles and they left some white. Right here, it keeps going littler and littler triangles. And they've done several inside one triangle, okay? So this is infinitely, you could do this, where it goes down smaller and smaller like that. You're taking a triangle and cutting it into smaller and smaller triangles. It's another way of doing it. Or you could do it inside each one, so it's just a whole series of different triangles going smaller and smaller and smaller. So there's a whole bunch of ways you can do this. You can look online to see. They don't necessarily tell you how all of them are made. I put geometric infinite series polygons.
Are we
Okay.
doing this now?
No, this will be something, I mean, you can think about it now.
I already
But-
know them, dude.
Okay. And then you're coloring it to make different kinds of pictures. Just a minute, stop. I have to get out of this.
Do you want us to do all those?
So this one, here we've got some in color with the red and the green and the blue down there.
This must be.
Okay, this is a bunch of rectangles and squares that you go down smaller and smaller. Okay, or you can do the infinite series in the middle. See how they did the triangle? This is all the midpoints of the triangle, and they just keep doing it. But it's kind of interesting to find out what happens if you just start with a four-sided figure like a trapezoid and start doing stuff. See what you get. It's kind of interesting to see what happens when you're doing them. Yes.
So we can't use circles.
Yes, I am allowing you to use circles.
Okay.
So you can actually do a circle and a rectangle, or circle
I'm
and
gonna do a square.
Do a circle and a triangle.
Doing a.
yes, you can do a circle and a triangle. Let me. I can't
Square,
hold this and
square.
do this at the same time. My arm is hurting. Let me see if I can find.
Doing an octagon, but no colors, they still get.
Okay, so here is one that's kind of interesting. It's got circles and triangles in it.
Whoa, that is kind of cool.
Okay, so see
Good luck.
that one? I don't know if you can see that. This one has a whole bunch of hexagons inside. Okay, so you can use hexagons, octagons. This one has a whole bunch of triangles.
Oh wow.
So there's just, this one is made from circles and triangles.
Do you have glue?
I still think that's a fun one. You can try whatever you want to see what you get. Okay, you just have to be able to explain what you're getting. Okay. This is one that's actually, they're using different shaped polygons, but the idea So they're using
Concave.
cave polygons, but they've put them together to make triangles and done some fun things with that.
That's kind of cool, actually.
So that's one of the things of your assignment that you're going to do. Actually, you're going to choose that or something else. Let's see.
Well, yeah, Harrison's gonna make us.
So this is another one. Look at this one is all done with squares and circles and some other weird figure. Okay.
Oh,
So that's kind of
is that a
interesting.
hexagon?
No, it's a pentagon.
It's a pentagon.
No, it's a hexagon. Sorry, I can't count. Harrison and I are gonna go learn how to count together. So this one does, I'm not sure what they're doing there. They may be doing midpoints of the different hexagon there. The hexagon and doing midpoints and midpoints and midpoints and
That's
see.
what I'm gonna do.
Okay,
Do
so
we have
there's,
to keep on doing the equations?
no, you have to do the equation. You just have to explain how you made it.
Oh, okay.
So just say like, I started with this figure and then I did this to go from there.
I might do like an octagon. Like
So
triangles
here's
like
some
this.
more pictures of different things like that. But see, some of these are the same thing, but they've colored them differently. And so do you see how that makes a difference? So we're trying to make some unique patterns, okay, with infinite series. Okay. And so it's kind of combining art and math at the same time. That's what a lot of art is. They do perspectives, they do shapes and sizes and start making patterns, and that comes in to be beautiful art. And so there's a lot of art and math tied together, okay? Because when you're doing a perspective, you have to get the perspective so it looks like it's going in for an infinite series. It's kind of like this. Your eye needs to be drawn in so it looks like there's 3D to it. And so that's perspective when you're drawing, okay? And so that kind of gives you that same idea.
First perspective.
So, yeah, I did geometric. Let me see what else I see here. Oh, yeah, there's all sorts of, so if you keep repeatedly doing it, there's something like that where you've done it over and over and over again. Okay, and so I want you to cover your whole paper with, I mean, it could be one type, or you could cover it with, like, do this several times, like around the whole paper, and that way it gives it a different look. Okay, and you can change colors, you can change anything to make it look different. Okay, the other thing we're gonna do, if you don't like that, if you don't wanna do an infinite series, the other thing we're gonna talk about, I can't spell it, tessellations, there we go. A tessellation is basically what you see a lot of times. Now you see infinite series also, they actually use those to make your tiles and floors and all that kind of stuff. But these are tessellations. So tessellation means to take different polygons or shapes like circles and fill your entire floor. So it's like covering the entire floor. So you have to have something that covers the entire floor. There's no blank spots. So think of it as putting tiles down and you can't have any blank spots on the tile. Okay. And so these are some examples. There are tons of examples. I was gonna say, this is one I did as a quilt. It looks like blocks that are stacked up. Okay, so I did that as a baby quilt for somebody one time, and that was a lot of fun to make. But it gives you that, it's just a bunch of different rectangles, really. But because of the color, it changes what it looks like. So this is playing with color and shapes, okay? You can do all sorts of weird things. This is a weird shape. It looks kind of like a fish, okay? But it's a tessellation because notice it's covered every part of the paper or every part of the floor. So just think about it. You can't put it down. You have to think about tile that goes down. So here's,
So that's what we're doing.
yeah, that's one of the ideas. So you can do it either just tessellations, or you can do tessellations with infinite figures,
Okay, yeah.
or you can do one big infinite figure that goes
Really small.
really small. Okay, so a lot of ideas to design something. Okay, but I just want you to get to know that, and look around you, see where tessellations are used, see where things are used that we're doing in here, infinite series. And these are used a lot for designs. They really are. They're used a lot for different designing things. Okay. So, and if I'll give you what to look up so you can get some ideas from that. Okay, let's do one last thing. On here. We already showed it's half. Let's do a triangle. We're going to do this triangle here to here to an isosceles triangle. Okay. So on this isosceles triangle, it's hard to see that black, isn't it? Let me write it. This is at the point 1, 2, 3, 4, 5, 6, 7, 8. So it's at 8, -8, and 4, -4. This one here is 0, -4. And this one here is 1, 2, 3, 4, 1, 2, 4. No, -4, 4. Okay, so those are the different points on our triangle. Where's the midpoint of this one? Right here. The midpoint of the base, the one on the bottom. What's the midpoint for the base?
-4, -4.
Yes, it is -4, -4 right here. So this is -4, -4. Okay, what's the midpoint on that one? The midpoint on one of we'll do the right hand side. What's the midpoint?
Just 0, -2.
0, -2. Okay, so it really is, because if I go up 1, 2, 3, 4, back 2, I go up 1, 2, 3, 4, back 2. This is the midpoint. So it is -2, 0. Okay, same thing here, except for what? Well, did I do that right? No, it's not. It's not drawn right. There, it's drawn more correctly. So my number here is -6, 0. I switched all the colors on it, didn't I? I can't draw straight, that's all I know. Okay, so we're gonna connect these. And in our book, when we looked at these, when we connect those midpoints, we got something that was half the size. Is that half the size of the other triangle? And which triangle is half the size? How many triangles do I get there when I did that?
4.
4, okay. So are all 4 of those the same size?
Seems like
How could you show that?
Or you find just one of the triangles, or maybe 2 of the triangles. Or since actually they are equal, because since the bottom is -8 and it's split at the midpoint.
Okay.
So 2 bottom lengths are -4.
Okay, so we know that these 2 are equal, right?
And then
What do we know about this one? What's its length?
and then since we know that to the right middle negative or middle point is -2, 0.
Okay,
And we know to the we know that it's you're not letting me go.
how would you find the distance from this point to this point? What would it be?
Oh, well, since it's also 8 from the middle. Can I just come up there?
Yeah, so you're saying this is 8.
Alright, so
Is that what you're saying?
This is what I was trying to, it's fine. That since this is 2, and then we know from here to here is also 2.
Okay,
If we add those 2, we'll get 4. And we
okay,
know that
you
this
see
would
how
be
he said that?
4
Okay.
as well.
Okay. What about this length? What do I know about this length? So what is this length here? What is the length of the big triangle?
8.
Is it 8? How would we find that? So we went from -4 down to 0, -4. So what was the length that I went in this direction, down? How far did I go down?
You went from 4 to -4.
Correct?
Yeah,
How
so-
far is
so
that?
that's 8.
8 squared plus, how far did I go in this direction? I went from -4 to 0,
So that's 4.
so it's 4 squared, okay? Square root, so this is 64 plus 16, okay?
That's right.
Square root of 100.
Root 11.
What is the length of this side? What's the length of that side? Is it 8?
No.
Wait, which side?
This side here, okay, so we're looking at this triangle. Now that will give us the hypotenuse. I did the calculations, what's the length of our side there?
10.
It's 10, the square root of 100 is 10. This one's gonna be the same because we know that these are the same and how we built it. But what we really have here is a triangle of 8, 10, and 10, okay? So the question was, are all the triangles the same? We know that this is a length of 4. We know that this, well, this is where we don't know yet. We know that's a length of 4. What is going to be the length of this one?
5.
5. What's going to be the length of this one? 5. The length of this one? 5. And 5. And 4. And what's going to be the length of this? 4. And 5. And 5. So are all of these triangles congruent? Yes, they are. And what size are they?
Medium.
How do they compare to the original triangle?
Other half.
They're half. Because if this is 10, 10, 8, and these are 5, 5, 4, they're half of it. So just by connecting the midpoints, you get 4 triangles that are the same size, or half the size of the other. Now, if you wanted to continue in this, you could find the midpoints again, and you could cut it again. Oops. Like this for each triangle, the midpoint here. Okay, and you get quite a design by doing this. I'm trying to figure out what am I doing here. Yeah. Okay, see, now you've got all sorts of triangles in there. Okay, and you could keep going. You could keep connecting that, and you could make it tinier and tinier and tinier and tinier. So if you wanted to do one whole page of just that, you can. Okay, so you can continue, but I just wanted to show you it is exactly half when we connect the midpoints in length. Okay, so that's something for you to know. Yes,
How did you get 100 squared?
because 8 squared is 64,
Yeah.
4 squared is 16.
They would be 80.
That would be 80, Thank you.
Yeah.
because I can't add.
So it's
It's the square root of 80. It's not an 8, 8, so it's the square root of 80, which is, I don't even know. Square root of 80 is, see, 70, let's see, what do we know? 9 is 81, so it's close to 9. Each of them is close to 9, so half of them would be about 4.5. Okay, so it would come out half.
Alright, so, but it's, the point is that.
The point is it's still, yeah. And again, you can continue to do that, and if you wanna make that into a series, and then you could add it to make this, so if you think about the floor, you could just do half of one here and half of one here. And you could make that to make it a rectangular shape, so you'd have to think about how to fit that on there. So the idea is to cover a page, 8.5 by 11 page. If you wanna do it bigger, that's fine, with some sort of design, but you have to be able to explain in words how you made the design. That I took the midpoints or something, what did I do to make this design? Okay, and then color it, and even if every one of you did the same design, if you color it differently, it will all look different based on how you color it. And you can color, you don't have to color each shape a different color. You could put similar colors in them, and you can do all sorts of things. I wouldn't make all of them the same color, that would be very boring. Okay, that would be very, very boring. Okay, so, if you want to start thinking about your design, I'll let you do that right now because we have some extra time. If you have not finished the homework, I will put that back up so you can do that, okay?
Yes.
Have you guys did you turn in 7.1 through 7.4, all of you?
I'm trying to.
7.1 through 7.4?
Wait.
That was the one that was due
Wow, you-
yesterday. Okay. So you get an easy day.
I don't think it. I just think it's- I'm gonna